be discussing the quotient rule a bit further by tackling two tasks. The key topics in this lesson are derivative rules and the criteria for using the quotient rule. Now, for our first task, we have to predict a rule that could be used to determine the derivative of quotients of the form y is equal to 1 over g of x, where g of x cannot equal 0. What do we need to know to tackle this task? We need to know what a quotient is, and a quotient is the result of dividing a quantity with another. In this question, we are given an equation in the form of a quotient, and so therefore the quotient rule is the most straightforward rule for finding the derivative in this question. We could also use the product rule as well, and in this lesson, I'll show us how to use both of them. Take a look at both rules and try to understand them. Pause if you need to. Now let's get to work. First, we need to figure out values for the function that we're given in the task that are similar to it. For this, we can just allow f of x to remain 1, and then we could make g of x be equal to 2x squared plus 2. That would give us the function 1 over 2x squared plus 2, and we have to find the derivative of this function. So this is f of x, and this is g of x. So for the quotient rule, we have to find f prime of x. So f prime of 1 is 0, multiplied by g of x here, subtract g prime of x. So g prime of x would be 4x, and this is because you bring the exponent down and you multiply it by the coefficient, it gives us 4, and you have to subtract the coefficient by 1, so 4x to the power of 1, multiplied by f of x, which is 1, divided by g of x squared, so 2x squared plus 2 bracket square. And then we can simplify that and reduce that. 0 times anything is 0. That leaves us with negative 4x times 1, which is negative 4x, divided by 2x squared plus 2 to the power of 2. That's our answer. Now, remember I also mentioned the product rule. So using the same equation from the previous example, we're going to use the product rule to differentiate it. First, we have to write this function in terms of the product. And to do that, we have to bring the denominator over to the numerator to multiply it by 1. And then we just have to make sure that the exponent turns to a negative. That's why this is what we have. And so this is the product rule. So this is our f of x, and we have to find f prime of x. F prime of 1 is 0, multiplied by our new g of x function, which is this whole thing, plus g prime of x, so g prime of this g of x, so g prime of this would be, to find the derivative of this, we would multiply negative 1 by this whole thing to the power of negative 1 minus 1, which gives us negative 2, and then we would multiply that by the derivative of this, which is going to be 4x, and then we would multiply it by f of x, which is 1. So let's reduce. 0 times anything is 0, so we're left with negative 1 times 2x squared plus 2 bracket to the power of negative 2 times 4x times 1. We can simplify these 3 that I underlined, which gives us negative 4x multiplied by 2x squared plus 2 bracket to the negative 2. So to make it a positive exponent, we just have to bring this over to the denominator, and that would change the sign of the exponent, and that's why we have negative 4x divided by 2x squared plus 2 to the power of 2, which is the same as the previous example. So we can use these two rules to find the same answer. Now, for task 2, take a look at these graphs. Also read the task, and as well as the need-to-knows, and then I will go over them with you. So I'm hoping you looked at everything and you tried it out. So basically on these graphs, I highlighted the parts that make it not differentiable. So over here, if you look at this pointy side, it's basically almost a straight line. You know that you cannot find the slope of a straight line. It does not exist. So therefore we cannot find the derivative. We cannot differentiate it. Over here, there is a discontinuity, and we know that limits are connected to derivatives and slope. So if the limit does not exist, we also cannot find the slope. And over here, it talks about a vertical tangent. You cannot find the slope of vertical tangents because it's just a vertical line, and you cannot find the slope of a vertical line. Now, to answer this specific task, we absolutely need to be able to differentiate f of x and g of x in order to use the quotient rule over here. And also, g of x cannot be equal to 0 because in a quotient, a denominator of 0 would give a vertical asymptote. And like we just talked about, a vertical asymptote is undefined, so a derivative would not exist at that point. Now for the optional multiple choice quiz, just look at the questions and pause, and then I'll play the answers right after. Thank you for listening.